Somebody the other day didn't even turn it on.
Okay, why Euler visited the mountain. If I mispronounce his name, especially since I'm on tape, that's bad. Why did Euler visit the mountain? Okay, first we got to set the stage for why he had to go up the mountain. And the deal was, y'all already know about inverse functions, or inverse relationships, inverse equations, or inverse functions, inverse relationships. Y'all learned about these in Algebra 2. And what happens is, if I have my function, and I put 2 into it, and the function makes it spit out a 5, if I put 5 into the inverse, and that little -1 right there meant inverse for you, then if I put 5 in there, it's going to make it turn back into the 2. That's what inverse functions do. It's like when you hit the undo key on your computer. And your computer is nothing but a big function machine. You put something in, it goes through the function, and it comes out. That's what your computer is. And so when you undo it, it just does the inverse. All right? Now, certain things about the inverse function are kind of cool. One is, if you have your original function, call that one f of x, and then you have your inverse function, the original and the inverse are symmetric with y equals x. Okay? Always remember your inverse and your original function are always symmetric with y equals x. So the cool thing is, if you know the graph of one of them, you can figure out the graph of the other one. Is that all right? Also, if I know that f of 2 equals 5, and f of 3 equals 7, and f of 5 equals 11, then I know what the inverse values are. I know that if I go over here and I do the inverse of 5, we're going to go back to 2. If I do the inverse of 7, we're going to go back to what? 3. And if I do the inverse of 11, we'll go back to 5. And that's what you learned in Algebra 2. And I know y'all did because y'all got good Algebra 2 teachers and y'all paid attention and you learned it. And you also learned how to write an inverse function. Okay, and that's what I want to show you for a second. How to actually write an inverse function. All right. To write an inverse function, if you know the original function, and we're not going to write anything up here real complicated. We just want to be able to show you enough that you know how it's done. F of x is equal to 3x plus 7. Something really simple. Now, how you do it, first thing is change the f of x to y. It just makes life easier. Okay? All right? Then you put a dotted line here so that you don't think you're doing algebra. And you switch x and y. You switch x and y. So you make that x equals 3y plus 7. And then after you switch them, solve for y. So make that -3y equals -x plus 7. Multiply both sides by -1/3 or divide by -3. Y equals 1/3 x minus 7/3. And then put f (-1) of x equals 1/3 x minus 7/3. Now, there's your original function, and there's your inverse. Okay? And if you want to test it, let's do a test. Let's put 2 in here, and if we put 2 in there, we get 13. Is that right? 6, 13. Now, put 13 in here. It better turn it back into what? 2. Travis, that you, I don't think it will. Yeah, it does. So that's going to be what? 13/3 minus 7/3, which is what? 6/3. And 6/3 is what? 2. And there you go. And that's how you find an inverse function. Okay? So, we know these inverse functions exist. We know how to do it. And we're pretty happy. All right. Now, the next step is we're going to look at some exponential functions. Yeah, we're going to talk about exponential functions for a few minutes here, and then you'll see that we're going to have to send him up the mountain. He's going to have to go up the mountain. We're going to name the mountain too. Story time in math world. Yeah, I'm trying to make it fun. Okay, here we go. Y equals, is it okay if I just make them y equals instead of f of x equals? Everybody, okay. Y equals 2 to the x. Well, if you put a -2 in there, I think everybody knows you're going to get 1/4 out. Is that okay? Because 2 to the -2, 4, and then take the reciprocal. Good with that? And then we'll do 0. Let's go ahead and skip to 0. Put 0 in there, we've got to get 1 out. Put 1 in there, we have to get 2. Substitute 2 in there, we have to get 4. Substitute 3 in there, we have to get 8. I'm going to go ahead and do 5. Substitute 5 in there, we have to get what? 32. Cool? Yeah. I mean, y'all know that. All right. Let's do this. Let's do y equals 5 to the x. All right. Put -2 in it, you have to get 1/25. Put 0 in it, you still get what? 5 to the 0 is 1. Then we're going to put a 1 in there, and we would put 1 in there. 5 to the first is what? 5. Then we'll put a 2 in there. 25, 3, 125. And that's enough for us to realize that we know how that works. Okay? And then, just to help me out, we'll do y equals 10 to the x. And if I do that, I put -2 in there, and I get 1/100. Put 0 in there, I still just get 1. Put 1 in there, I get 10. Put 3 in there, I get 1,000. And that's enough of those. All right. Now, so, let's talk about the inverse of each one. Okay? Let's talk about the inverse. Does everybody agree the inverse for this one would be, if you put 1/4 in, you'd have to get what? -2, right? If you put 1 in, it's got to turn back into what? 0. If you put 2 in, it's got to turn back into 1. You put 4 in, it's got to turn back into 2. You put 8 in, it's got to turn back into 3. And you put 32 in, it's got to turn it back into a what? 5. Because we know how inverse functions work. Now, this one, same idea. Let's make us a list of what the inverses would have to do. See, we already know the points that would be on the inverse graph. If these points are on the original graph, these points are on the inverse graph. Right? Good with that? Okay, so, it's hard to read y'all's thoughts when I can't see your whole face. 125, 2, and then 3. And then we'll go ahead and put this one over here in the way. Yeah, 1 over 100 would have to be -2. 1 would have to become 0. 10 would have to become 1. And 1,000 would have to become 3. So, those would be our inverses, right? Those are our functions with a -1 above them. Those are our inverses. So, all the mathematicians said, well, we need a formula for that inverse. We need a formula for this inverse. We need a formula that makes this happen. We know there's one out there that turns 1 into 0, 2 into 1, 4 into 2, 8 into 3, and 32 into 5. Because we know there's these things called what? Inverse functions. So, let's do it with 2 to the x. Let's go over here, take your paper, and do the little trick for finding inverses. Go ahead and start working your inverse formula that I just gave you. How do you find inverses? Swap the x and the y, and then do what? Solve for y.
Wait, what's the formula?
Well, okay, remember I wrote the list down over here?
Mm-hmm.
I want you to do that so that you can get the formula.
Okay.
Yeah, I want you to do that so you can get the formula. I want to do the little y equals 2 to the x. Then I want you to put your little dotted line and make that x equals 2 to the y. And then I want you to figure out how to make it y equals. I'm between belt loops. I'm going to have to get a drill and these belt loops in this belt. Either that or I'm going to have to decide to eat more. I'm not going to try to go back down to the smaller ones, to eat more and get up to the bigger ones. Do you notice you have a little bit of problem figuring out a way to make that happen? Yeah. Bad day. No algebraic. Yeah. It turns out for these exponential functions, there is no way to algebraically find the inverse. We know there is an inverse. We even know the values of the inverse. But this is why Euler had to visit the mountain. Is because the way that we had always found inverse functions wouldn't work. You couldn't use good old algebra and this nice method that works for lots and lots of problems. You couldn't use it to find the inverse of exponential functions. And that is why Euler visited the mountain. And it's good for you to see it. I mean, y'all tried to work it, and y'all are good with algebra and good at manipulating the numbers. And all of a sudden, you can't make it happen. And that was the same problem that Euler had.